The emergence of cast iron as an architectural material captured the imagination of the urban public in ways that few building materials had in the past or would in the future. The building material appeared at a time when American cities were being transformed from three-story brick and stone buildings to enormous and powerful industrial centers whose buildings reached skyward. Cast iron and steel would ultimately serve as an important link in the evolution of commercial buildings from their residential ancestors to modern skyscrapers. Cast iron is a group of iron-carbon alloys that has a relatively low melting point, good fluidity, mechanability, resistance to deformation, and wear resistance. The earliest cast iron artifacts date to the 5th century BCE and were discovered by archaeologists in China. It was used in ancient China for warfare, agriculture, and architecture. Cast iron was not utilized in the West until the 15th century for artillery in Burgundy, France, and England during the Reformation. In 1700, the iron industry was in downward trajectory. Ironworkers required charcoal to smelt the iron ore, are known in the 18th century as ironstone in the furnace. Charcoal, however, was in short supply as the wood required to make charcoal was expensive. This posed as an industrial problem. In the course of a century, however, uncritical and substantial change occurred as coal, or coke made from coal by much the same process as charcoal is made from wood, replaced charcoal as a fuel used in the smelting process. This process is what typically separated iron from ironstone. The result of this change revolutionized the industry and the use of iron and steel. The materials were now cost efficient and were supplied mainly in Britain. This extended the use of iron in the construction industry and added the longevity of this material.
This discovery happened within the 18th century and was down to 3 generations of one family. The Darby family solved this problem. Abraham Darby, approximately in 1709, was the first of 3 generations within his family to become an iron master. Having initially worked with brass, Abraham decided to relocate to Coalbrookdale in Shropshire, where he bought a semi-derelict blast furnace. This was where he first successfully used coke instead of charcoal to fuel the furnace. The success of Coalbrookdale and the business of Darby meant he was able to open a second blast furnace in 1715. This progress and enhancement of his business would have been progressed even further but for his death within 1717.
He was succeeded by his son Abraham Darby II, who took his father's work to the next level when he found out how to make the better coke by burning coal in ovens. This coke made the quality of iron better, and with the 2 furnaces with Coalbrookdale business continued to boom. Abraham Darby II died in 1763, taking with him a superior reputation for his gift in combining managerial skills with technological innovation. Following his death, Abraham Darby's operations were continued by his son, Abraham Darby III, who is renowned for his creation of the Iron Bridge, which was the first of its kind in the world. This was constructed above the River Severn using iron from the furnace made famous by his late grandfather. Steel was stronger and less brittle than iron, but difficult to make. This process was made far simpler in 1856 when Henry Bessemer invented the converter. This helped the process and turned molten iron into steel in 20 minutes. The advancements in steel and iron made industry flourish, and the exploits of the Darby family are to thank for this.
Iron and glass were often combined in the 1800s in construction of conservatories, especially in England and France. Early examples that are still surviving include the Syon House Conservatory, located in Middlesex, designed by Charles Fowler, and the Palm House, located at Kew Gardens by Decimus Burton. The design of these airy, naturally lit spaces, designed using metal and glass, eventually led to the height of early Victorian architectural technology, the Crystal Palace. Designed by Sir Joseph Paxton, the Crystal Palace was a glass and iron exhibition hall located in Hyde Park, London, which housed the Great Exhibition of 1851. It was built to house an international exposition dreamed up by Prince Albert and Queen Victoria. Sir Joseph Paxton designed the exhibition hall to be constructed from prefabricated parts consisting of a complex network of slender iron rods holding up clear glass walls. It was innovative in the fact that it used standardized materials, rapid assembly, and its main architectural innovation was its ability for massive spaces.
The main body was 1,848 feet long and 408 feet wide, with a height of 108 feet in the center hall. The total floor area throughout the hall was about 990,000 square foot, or about 23 acres, and consisted of display tables and galleries. The exhibition opened on May 1, 1851, and ran until October 15, drawing in over 14,000 exhibitors and 6 million visitors. After the closing ceremonies, the Crystal Palace was taken down and reassembled at Sydenham Hill, where it stood until 1936, when it was almost completely destroyed by fire. The surviving towers stood until 1941 and were finally demolished because they were deemed a conspicuous landmark for incoming German bombers during World War II. The Crystal Palace was an immense structure designed for the purpose of the Great Exhibition of 1851, although it was still used afterward for shows, exhibitions, concerts, and soccer matches. It is important because it established the architectural standard for later fairs and exhibitions that also drew upon the idea of being housed in glass conservatories. In fact, the Crystal Palace restaurant in Walt Disney World Resort in Orlando was inspired by London's Crystal Palace and designed to look like it.
An example of French iron and glass construction would be Henri Lebros's 9-domed reading room at the Bibliothèque Nationale in Paris. Gustave Eiffel was one of the most notable engineers and designers at his time in Paris. Working with architect Louis Boileau in 1876, they designed the Bon Marche, a retail center where items were displayed around the edges of skylit interior courts, much like early conservatories. Later, in 1887 to 89, Gustave Eiffel left his biggest mark when he designed a structure for the Paris Exhibition of 1889, which people still identify with France today, the Eiffel Tower. His plan won over more than 100 other plans submitted for the competition, with a concept to build a 984-foot tower using an open lattice wrought iron structure. Across the Atlantic, the United States was also using metal and glass construction in new ways. Large office buildings, banks, railroad terminals, and warehouses started using metal construction and started building upward. The push to build skyward was due to the expensive cost of urban property, a desire for commercial prestige, and for close proximity because of lack of rapid communication. The new invention of the elevator also made moving upward much quicker. Most new tall buildings, however, still resembled towers of smaller masonry buildings stacked together, like Hunt's Tribune Building in New York City. In 1884, Chicago engineer William LeBaron Jenney solved this structural problem in the home insurance company building by developing a metal skeleton of cast iron columns sheathed in masonry and wrought iron beams which carried masonry walls and windows for each floor. Most Chicago architects, later known as the Chicago School, began seeking better aesthetic expression in metal frame buildings. William LeBaron Jenney's later Building 2 in 1981, later known as Sears Roebuck & Company's main retail store, and Burnham and Root's Monoduct Building in 1891 were both the first modern commercial buildings in Chicago that showed formal simplicity and ornamental abstinence in their designs. Later, Burnham went on to design the Reliance Building in Chicago from 1890 to 95, which was another example of a steel skeleton building with faceted walls of glass covered with terracotta panels. Finally, by the end of the 19th century, modern commerce was described by the steel skyscraper. It became an important emblem of it, with a structure made of steel, efficiently planned spaces, and elevations expressed by the skeleton.